Luftwaffe Mi-109 seconds couldn't start below -25°F, while Soviet Yak-1 second flew at -40°F from the same airfields. German bombers had engines that cracked in the cold. Hydraulic fluid froze in gun turrets. Fuel turned to gel on the runway. This isn't about aircraft shot down, it's about aircraft that never left the ground when armies needed them most. Junkers Ju-87 Stuka. The Junkers Ju-87 was a mechanically simple dive bomber designed for accuracy, visibility, and close coordination with ground forces. Its fixed landing gear and straightforward systems made it one of the more rugged aircraft in the Luftwaffe inventory. In winter, however, its apparent simplicity could not overcome environmental neglect. German cold weather preparation was inadequate during the first Eastern Front winters, and the Stuka relied on heavy engine oils that thickened into sludge overnight. Without sufficient heated hangars or standardized cold start equipment, engines often could not be turned over at all. The aircraft's failure was not sudden mechanical collapse, but operational paralysis. Soviet crews diluted oil with fuel and used open fires beneath engines to keep aircraft flying, while German units were slower to adapt. As a result, the Ju-87 was frequently grounded during periods when air support was most needed, reducing its impact despite remaining structurally sound. Junkers Ju-52 Thirdsam. The Junkers Ju-52 was the logistical backbone of the German Air Force, responsible for transport, evacuation, and airborne supply. Its tri-motor design emphasized reliability rather than speed or protection. Extreme winter conditions exposed its limits during sustained operations. The BMW 132 radial engines were notoriously difficult to start in deep cold, and repeated cold starts caused accelerated wear. Snow-covered runways lengthened takeoff rolls beyond safe margins, particularly when aircraft were overloaded during emergency airlift missions. The Ju-52's corrugated duralumin skin created additional problems. Ice accumulated within the grooves of the metal, adding weight and degrading lift, while de-icing by hand was slow and dangerous. In winter supply operations, especially during encirclement scenarios, aircraft were lost not to enemy fire but to weather, overloading, and mechanical failure before leaving the ground. Mitsubishi, a 6M0, Aleutian operations. The Mitsubishi A6M0 was designed for long range, lightweight, and maneuverability in warm maritime climates. Its success in the Pacific relied on minimal armor, minimal insulation, and finely tuned systems optimized for temperate air. In the Aleutian Islands, these design choices proved disastrous. The Zero lacked effective cockpit heating, camera heating, and wing de-icing systems. Pilots faced extreme cold, freezing fog, and violent winds known locally as williwaws, often suffering frostbite while flying aircraft that could not shed ice. Operational losses mounted due to weather rather than combat. The famous Aleutian crash that led to the capture of an intact Zero illustrated how environmental disorientation and icing could neutralize even an elite aircraft. In Arctic conditions, the Zero's strengths became liabilities, and its operational value collapsed. Heinkel, He-111. The Heinkel He-111 served as a principal German medium bomber throughout the war. It was adaptable and widely used, but its systems were never optimized for sustained extreme cold operations. Winter exposed weaknesses in its Jumo 211 engines and supporting equipment. The Luftwaffe lacked sufficient preheating wagons, forcing ground crews to improvise by channeling hot exhaust air from trucks into engine nacelles. These methods were slow, inefficient, and dangerous. Once airborne, cold air pouring through open defensive gun positions caused mounts and ammunition feeds to freeze solid. Even when bombers reached their targets, defensive capability and reliability were compromised. The He-111 continued flying, but winter stripped it of efficiency and survivability at the very moment sustained bombing was required. Petlyakov P-2. The Petlyakov P-2 was a fast, modern Soviet dive bomber designed for aggressive, high-speed attacks. It relied heavily on electric motors and tightly engineered systems, which made maintenance demanding even in ideal conditions. In extreme winter environments, these systems suffered from cold-induced electrical failures. However, Soviet operational culture mitigated some disadvantages through winter-specific practices, including indigenous lubricants and rapid field maintenance supported by propeller-driven sled transport. The P-2's most serious winter vulnerability emerged during landing. Its high landing speed and narrow landing gear proved unforgiving on packed snow and uneven ice, leading to frequent collapses. The aircraft remained effective, but winter conditions sharply increased non-combat losses and reduced operational tempo. Early Arctic Ferry B-17 Flying Fortress. The B-17 Flying Fortress was engineered for high-altitude bombing and structural durability. Early in its service life, Arctic ferry routes tested those qualities under the harshest possible conditions. Extreme cold caused oil to congeal within the oil coolers, while engines were still running, leading to sudden oil starvation and mid-air engine seizures. Icing, brittle metal stress, and limited emergency landing options made weather as lethal as enemy fighters. Aircraft were lost before ever reaching combat units, forcing rapid procedural changes and equipment upgrades. The B-17 ultimately adapted, but its Arctic experience demonstrated that even the most robust bombers were vulnerable when cold overwhelmed engineering assumptions. Focke-Wulf FAV 190A Eastern Front Early Operations. The Focke-Wulf FAV 190 entered service as one of Germany's most advanced fighters, prized for its firepower, durability, and the powerful BMW 801 radial engine. In temperate conditions, it proved superior to many contemporaries. Early Eastern Front winters exposed a critical weakness: cold weather engine management. The BMW 801 relied on precise tolerances and oil systems that struggled in deep cold. Oil thickening, magneto issues, and frozen engine accessories made cold starts unreliable, particularly at forward airfields lacking proper preheating infrastructure. Unlike simpler fighters, the FAV 190 demanded disciplined ground support that winter conditions rarely allowed. Aircraft availability dropped sharply, not because the fighter was ineffective in the air, but because engines could not be safely started or sustained. Winter reduced one of Germany's most capable fighters into a grounded asset during key phases of the campaign. Fiat BR-20 Cicogna Italian Air Force in Russia. The Fiat BR-20 was Italy's primary medium bomber at the start of the war, designed for Mediterranean climates and moderate operating conditions. It was deployed to the Eastern Front with Italian expeditionary forces to support Axis operations. Russian winter conditions overwhelmed the aircraft almost immediately. Engines suffered from oil congealment, fuel system issues, and frequent starter failures. Structural materials and seals not designed for extreme cold cracked or leaked, while defensive armament became unreliable in freezing airflow. Operational losses mounted rapidly without significant enemy engagement. Bombers were grounded, abandoned, or written off due to weather-related damage. The BR-20's experience demonstrated the fatal cost of deploying climate-inappropriate aircraft, and it became one of the clearest examples of winter rendering an entire bomber force combat ineffective. Across every front, winter revealed a universal weakness in wartime aviation. Aircraft were only as effective as the ground systems that supported them. Cold thickened oil, froze hydraulics, shattered tires, and locked weapons in place. Ground crews resorted to open flames and blowtorches to thaw engines, sometimes burning aircraft to the ground before takeoff. Rubber tires became brittle, flat-spotted, or failed outright upon landing. These aircraft did not fail because they were poorly designed. They failed because winter warfare punished unprepared logistics, inadequate doctrine, and environmental underestimation. In the Second World War, winter was not a condition to be endured. It was a force that grounded air power, reshaped strategy, and proved that climate could be as decisive as any weapon.